Good morning, one and all present here. I am Dr. Yuvraj, Assistant Professor, Mechanical Department from SNS Technology. So, welcome to the Dr. GV lecture series, and today I am going to speak about the topic that is from unit number 2, Design for Additive Manufacturing, from the subject of Additive Manufacturing. So in the first unit, we just have discussed what is additive manufacturing, what are the types of additive manufacturing is there, and what do you mean by rapid prototyping, what kind of softwares that we are using to design the component, and what is the stages that involved in the additive manufacturing, and accordingly we have to plan the manufacturing operations. And what do you mean by pre-processing, what do you mean by post-processing, in between the stage that is in slicing stage, and finally what is the output product that we going to get it by using their additive manufacturing, and what are the machining operations, not in machining operations, it is an layer by layer manufacturing, how the layer by layer has been manufactured. In this thing we just studied, we have come across so many instances in the particular object. So that is what the primary of additive manufacturing. So this is what I discussed in earlier. Okay, so generally in additive manufacturing we have to prefer for design for additive manufacturing, that is for CAD model preparation and the optimization. So this is the primary thing. What do you mean by CAD model preparation, and what do you mean by optimization? So this is what we need to know. Okay, so here this session, which is entirely deals about the designing process, about CAD model preparation, how to design the component by using the CAD model. Following that, what parameters that we need to optimizing for the additive manufacturing. The first one, CAD defines the geometry. So the importance of CAD in additive manufacturing is we have to define the geometry and as well as the feature precisely. So while we designing the component, we have to mention the input parameters like dimensions, thickness and layers, and what material that we are using, how that material has been executed into layer by layer. In this thing, how the structures has been keep on varied. In all aspects we have to understand about their CAD parameters. So that is why we need to design the component by using the CAD model. Okay, so that is the first thing. And the second one, while we design the component, we have to do the design for assembly and manufacturing principles. So design for assembly and manufacturing, generally this subject, it is entirely deals about before the object comes into the production. That object has to be designed with respect to their factor of safety, with respect to their specification of manufacturing like tolerances and the design values, core design values. Accordingly we have to prepare the object in that way. Okay, so for designing the component we have to applying some basic laws which has been followed in design for assembly and manufacturing. That is why we have to applying the principles. And in the third one, we can able to determine the manufacturability. We need to determine the manufacturability, which means whether the component which has been designed by using the software, whether it can able to fit to be manufactured or not. So for this thing we have to understand whether the designed component is as per the standards, whether the standards has been followed for the manufacturing or not. Accordingly we need to design the component in different kind of stages. So that is why we have to check design for manufacturability. And following that we have to determine the basis for slicing and printing. So once the component is designed as per the requirement of the product, and whether we have to assess whether it can fit for the printability or not, that is in manufacturing. Once it has been done, we have to make it for slicing. So we have to do the slicing and the printing of the printing on the basis of the slicing and the printing of the object. Once it has done, we have to do the procedure like slicing process. So for this thing we having a multiple what do you call that, we have the multiple process like an precursor 3D and 3D Tinker CAD and 3D CAD, and these are the various softwares which we are used for this slicing. Once the slicing has been done, this command has to be transferred to the manufacturability. So that is why we need to concentrate on basis for slicing and the printing. Okay. So file optimization and file optimization in the design in the CAD. Here, simplify the geometry to reduce the file size. Okay, so whenever we design the component, we have to simplify the geometry to reduce the file size, which means we have to focusing on that geometrical designs. It should be in the as per the file format or according to the structure transformation from the 3D printing. So every 3D printer have the basic structured range. Okay, in that structured range we have to prepare the component according to the 3D printer requirement. Hence we need to simplify to reduce the file size and remove the unnecessary edges, which means okay, based on the standard size, we have to remove the all other components, that unwanted components, and we have to optimize for the printer capabilities. And it has to be maintain the fidelity, that is functional fidelity, whether it can whether the color ranges or whether the zooming shapes or inside the layer by layer it has been done it properly or not. For that it has to be maintained the functional fidelity. So in this range we need to do the optimization. That is why we need to go for the file optimization. And the fourth stage, it is about the error checking. So generally error checking means it is not about to determine the dimensions, but also it is about whether it can fit for the manufacturing or not, that we need to do the error checking. For this thing we have to meshing the shapes of or meshing the size of the images in the various sizes, and based on the identification of the holes and the non-manifold edges which has to be done, and it has to be undergone the repair the measures and ensure the waterless geometry, or else we have to prevent the failed prints. So based upon that the CAD import design has to be done. So according to the CAD import, the measures and as well as the manifold edges which has keep on varying designs, and we have to do the error checking for the particular shape in the particular type of analysis. So based upon that we come to the decision to do the understanding about the components. Okay, thank you so much.